The date is June 19th, 1944, and above the Philippine Sea, Lieutenant Alexander Vraciu is about to commit what every fighter pilot manual, every tactical instructor, and every combat veteran would call suicide. His F6F Hellcat, that corpulent 12, null-pound beast of American industrial excess, is turning hard into a Mitsubishi Zero, that graceful Fünf, 300-pound instrument of aerial perfection. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. He is deliberately entering a turning fight with an aircraft that possesses a turn radius 30% tighter than his own. The geometry should guarantee his death. But Vraciu is not just surviving, he is winning. In the next 4 minutes, he will shoot down 6 Japanese aircraft, a feat so statistically improbable that it defies the mathematical reality established over 3 years of brutal aerial combat. More remarkably, he is not alone. Across the vast, churning expanse of the Philippine Sea, dozens of American pilots in their heavy, overbuilt Hellcats are engaging in sustained turning fights with Zeros, and emerging victorious at a rate that renders the previous 3 years of tactical doctrine obsolete. The kill ratio for this single day, later immortalized as the Great Marianas Turkey Shoot, will reach an almost obscene 13-1 favor of the Americans. This was not the result of better training, superior numbers, or lucky circumstance. This was the culmination of a deliberate, calculated revolution in fighter tactics that had transformed the fundamental physics of aerial combat. To understand how American pilots began turning inside a circle they had no geometric right to enter, we must first return to the source of the impossible problem. The Mitsubishi RSX-M0 was not merely a good aircraft. It was a philosophical statement rendered in aluminum and fuel. Every design choice, every omission, every carefully calculated pound removed from its frame represented a Japanese commitment to a specific vision of air combat, the supremacy of maneuverability. The technical specifications told a story of almost spiritual dedication to lightness. The Zero's empty weight hovered around dry 700 pounds. The production F6F Hellcat tipped the scales at nearly 9 pounds empty. This was not a minor difference. This was a fundamental chasm in design philosophy. The Japanese engineers had sacrificed everything: armor plating, self-sealing fuel tanks, heavy ammunition loads, pilot comfort on the altar of turn performance. The result was an aircraft that could complete a full 360-degree turn in roughly 16 seconds at optimal speed and altitude. The early model F4F Wildcat required nearly 23 seconds for the same maneuver. The geometry was unforgiving. In a turning fight, the Zero could point its nose at an American fighter before that fighter could point back. This advantage translated directly into kills. The pilot who points first shoots first. The pilot who shoots first survives. For the first 2 years of the Pacific War, this geometric superiority was absolute law. American fighter pilots learned through the brutal instruction of death that entering a turning engagement with a Zero was not combat, it was assisted suicide. The tactical manuals were explicit. Never turn with a Zero. Use your speed. Use your diving performance. Hit and run. Disengage vertically. Preserve energy. These were not suggestions. They were commandments written in the blood of dead American pilots who had tried to violate the physics. Yet by Mai 1944, something had fundamentally changed. The geometry was identical. The Zero's turn radius had not increased. The Hellcat was still heavier, still less maneuverable by every traditional measure. But American pilots were now routinely surviving and winning sustained turning engagements against the same aircraft that had previously rendered such fights impossible. The revolutionary insight did not come from the aircraft designers at Grumman. It came from a small cadre of combat pilots who recognized that the problem was not the turn itself, but the nature of energy management within the turn. The Zero's superior turn rate was predicated on a specific set of conditions: optimal airspeed, optimal altitude, and most critically, a clean, uninterrupted circular flight path. These conditions existed only in the theoretical vacuum of a tactical classroom. In actual combat, the three-dimensional chaos of a dogfight introduced dozens of variables that could be weaponized against the Zero's presumed advantage. The key was understanding that turn radius and turn rate were not fixed values but dynamic equations influenced by speed, altitude, power output, and crucially, the timing of the turn entry. The breakthrough came from recognizing a counterintuitive reality. The Hellcat could not outturn the Zero in a sustained circle, but it could generate a momentary angular advantage at a specific critical point in the engagement geometry. This advantage, measured in fractions of a second and mere degrees of deflection, were sufficient to reverse the kill equation. The tactical innovation was called the high-side guns pass, with a snap reversal, though pilots simply referred to it as turning into him. The maneuver exploited three specific Hellcat advantages that had nothing to do with turn radius: superior roll rate, superior power-to-weight ratio at high speeds, and superior structural strength. Here is how the impossible geometry became possible. An American pilot, spotting a Zero at his altitude or slightly below, would initiate a shallow diving attack, building speed to approximately 350 knots, a velocity at which the Hellcat's massive Pratt Whitney Reitz 2800 engine delivered its peak power, and the Zero began to encounter compressibility issues with its light airframe. As the Zero pilot, recognizing the threat would break hard into the attack, initiating his superior turn, the Hellcat pilot would not attempt to follow in a conventional turning pursuit. Instead, he would execute a violent snap roll, using the Hellcat's superior aileron authority to instantly reverse his bank angle, then pull into a maximum G-turn in the opposite direction. This maneuver created a geometric paradox. The Zero, committed to its initial turn and bleeding energy in the process, was now pointed away from the threat axis. The Hellcat, having used its superior roll rate to reverse direction and its superior power to maintain speed through the pull, was now entering a turn from a higher energy state. For a critical 2 to 3 seconds, the Hellcat's nose was tracking across the Zero's future position faster than the Zero could complete its circle. This was not sustainable. If the engagement continued beyond those crucial seconds, the Zero's superior sustained turn rate would reassert dominance. But 2 to 3 seconds was an eternity in aerial gunnery. The Hellcat carried 6. The Hellcat carried 6 50 caliber Met-2 Browning machine guns, each firing 800 rounds per minute at 400 yards. The convergence point of all 6 57.0 guns created a cone of destruction measuring roughly 30 feet in diameter, delivering over 160 rounds per second into that lethal space. The Zero's lack of armor meant that fewer than 10 rounds striking critical areas engine, fuel tanks, control surfaces would render the aircraft unflyable. The probability mathematics were brutal and decisive. The Hellcat pilot did not need a perfect shot. He needed only to place his gun sight within 50 feet of the target for 1.5 seconds. The sheer volume of lead made the kill a statistical certainty. The tactical revolution was not in teaching pilots to turn tighter. It was in teaching them to weaponize their aircraft-specific strengths, speed retention, roll authority, and overwhelming firepower to create momentary geometric windows that rendered the Zero's sustained turn advantage irrelevant. The impossible had become routine. By June 1944, this doctrine had been systematically integrated into every fighter training syllabus, every tactical briefing, every combat mission profile. The American pilot was no longer fleeing from turning engagements. He was initiating them, deliberately forcing the Zero into the exact geometric scenario where American advantages could be maximized and Japanese advantages could be negated. The result was not merely tactical superiority, it was a complete inversion of the psychological battlefield. The Zero pilot, for 3 years the unchallenged master of the turning fight, now faced an opponent who refused to follow the rules. The American pilot who turned toward him was not making a mistake, he was executing a calculated trap. The geometry that had guaranteed victory now promised only confusion and death. This revolution in fighter combat was not the product of a single brilliant insight or a revolutionary technological breakthrough. It was the synthesis of 3 years of brutal trial, systematic analysis, and the calculated exploitation of specific material advantages. Hellcat did not defeat the Zero by becoming more maneuverable. It defeated the Zero by changing the definition of what maneuverability meant in combat. The Dreitzen to 1 kill ratio was not luck, it was geometry weaponized by industry and perfected by doctrine. To understand why the Hellcat could suddenly turn inside a circle, it had no geometric right to enter. One must first abandon the comfortable mythology of the better aircraft and confront the raw, unforgiving mathematics of horsepower, weight distribution, and energy management. The revolution was not metaphysical, it was thermodynamic. The heart of the tactical transformation beat inside a single component, the Pratt Whitney R2800 Double Wasp, an 18-cylinder, 2-row radial engine that represented the apotheosis of American mass production applied to aviation power plants. This machine, weighing 2,360 pounds and displacing 2,804 cubic inches, generated 2,000 horsepower at war emergency power settings. To place this in proper context, the Nakajima Sakai engine that powered the Zero produced 130 horsepower from 560 cubic inches. The raw numbers told only part of the story. The critical revelation was not in peak horsepower, but in power delivery across the flight envelope, particularly at high speeds where compressibility effects and control surface authority began to dictate combat outcomes. The 2800 was designed with a 2-stage, 2-speed supercharger that maintained power output at altitudes exceeding 20,000 feet. The Sakai, optimized for low-altitude performance and fuel efficiency, began hemorrhaging power above 15,000 feet. This power differential created a velocity regime where the Hellcat's performance characteristics inverted the expected relationship between weight and maneuverability. At speeds below 250 knots, the Zero's lighter wing loading and lower stall speed gave it undeniable turning superiority. But at speeds above 300 knots, the Zero's control surfaces became increasingly sluggish, its roll rate degraded, and its structural limits prevented aggressive maneuvering that the Hellcat's robust airframe could sustain. The tactical implications were revolutionary. Previous American fighters, the F6F Wildcat, the Pierzig Warhawk, lacked sufficient power to routinely operate in this high-speed regime while maintaining combat maneuverability. They could dive to gain speed, but the moment they pulled into a turn to engage, their inferior power-to-weight ratios bled velocity so rapidly that they fell back into the Zero's optimal performance envelope. The Hellcat, by contrast, could sustain 320 bis 340 knots in level flight, pull 5G turns while maintaining 280 knots, and more crucially, could rebuild that lost energy within seconds through the application of war emergency power. This was not a minor tactical advantage, this was a complete redefinition of fighter combat geometry. The key tactical innovation was the speed bleed reversal, a maneuver that deliberately sacrificed the Hellcat's speed advantage to create a positional advantage, then exploited superior power to rebuild that speed before the Zero could capitalize on its momentary turning superiority. The execution required precise timing and an intimate understanding of energy states, but the results were devastatingly effective. Consider the engagement geometry. A Hellcat pilot at 340 knots spots a Zero at co-altitude, ranged 2,000 yards. The Zero pilot, recognizing the threat, brakes hard left, entering a maximum performance turn. Traditional tactical doctrine dictated that the Hellcat pilot should extend, climb, and re-engage from an energy advantage. But the new doctrine demanded something radically different: turn with him. The Hellcat pilot would simultaneously reduce throttle to 75%, deploy combat flaps, and enter a hard turn, accepting a massive speed bleed from 340 to 240 knots in roughly 4 seconds. This placed the Hellcat momentarily at a severe energy disadvantage. The Zero, completing its turn at optimal speed, would appear to have gained the superior position. But this was the trap. The Hellcat's superior roll rate, approximately 110 degrees per second, compared to the Zero's 75 degrees per second, allowed the American pilot to snap his wings level, firewall the throttle to war emergency power, and enter a vertical or oblique climb while the Zero was still completing its horizontal turn. The at 2800, generating maximum thrust, would accelerate the Hellcat from 240 to 310 knots in 6 seconds while climbing at 500 feet per minute. The Zero pilot, having expended his energy in the turn and committed to a horizontal pursuit, now faced an opponent who had converted horizontal positional advantage into vertical separation while rebuilding speed. The Japanese pilot had 3 options: attempt to follow into the vertical, extend and disengage, or reverse his turn to maintain horizontal pursuit. All 3 options favored the Hellcat. If the Zero followed into the vertical climb, its inferior power-to-weight ratio at high speeds meant it would stall first, presenting a near-stationary target. If it extended, the Hellcat could reverse, dive, and re-engage with both speed and altitude advantage. If it reversed to maintain pursuit, it entered a sustained turning fight at speeds where the Hellcat's power advantage negated the Zero's maneuverability advantage. This was energy management weaponized into a systematic killing doctrine. The American pilot was no longer avoiding the Zero's strengths. He was deliberately drawing the Zero into a specific energy state where those strengths became irrelevant, then exploiting superior power to create a kill opportunity before the engagement could evolve into a sustained turn fight. The second critical component was structural advantage, translated into tactical aggression. The Hellcat's airframe was designed and stressed for 7,5G positive and 3G negative load factors with a 50% safety margin. The Zero's airframe began experiencing structural failure above 8Gs and was particularly vulnerable to high-speed aileron reversal, a phenomenon where excessive roll input at high speed would cause the wing to twist, producing roll in the opposite direction. This structural disparity created a velocity-dependent regime where aggressive maneuvering became a weapon in itself. Hellcat pilots learned to initiate sharp high-G reversals at speeds exceeding 320 knots, maneuvers that the Zero simply could not match without risking catastrophic structural failure. The Japanese pilot was forced to moderate his control inputs, creating lag time that the American pilot could exploit. The third element was firepower, density, and ammunition capacity. The Hellcat's 6.50 caliber guns carried 400 rounds total, providing approximately 20 seconds of continuous fire. The Zero's 2 20mm cannons carried 120 rounds total, roughly 7 seconds of fire. This disparity created fundamentally different gunnery doctrines. The Zero pilot, constrained by limited ammunition, needed to achieve a perfect firing solution: close range, minimal deflection, sustained tracking. This required the extended turning engagement where the Zero's maneuverability advantage could be fully exploited. The Hellcat pilot, blessed with abundant ammunition, could afford to fire in shorter bursts at greater range with higher deflection angles. The gunnery problem was transformed from precision marksmanship to statistical probability. At 400 yards with 30 degrees deflection, a 2-second burst from a Hellcat's 6-gun battery would place approximately 320 rounds into a cone measuring roughly 60 feet in diameter. The Zero, lacking armor and self-sealing fuel tanks, required only 8 bis 12 hits to render it unflyable. The probability of achieving that hit density in a 2-second burst at moderate deflection exceeded 40%. The Hellcat pilot did not need to turn inside the Zero's circle. He needed only to point his nose close, enough to the Zero's future position for long enough to make the statistics work. The cumulative effect of these three factors, superior power for energy management, superior structure for aggressive maneuvering, and superior firepower for statistical gunnery, created a tactical environment where the traditional metrics of fighter performance became irrelevant. Turn radius, measured in degrees per second, mattered less than energy recovery rate, measured in knots per second. Sustained turn capability mattered less than instantaneous roll authority. Precision gunnery mattered less than ammunition density. The Hellcat was not outturning the Zero. It was changing the rules of what turning meant in combat. The Japanese pilot who entered a turning engagement, expecting to exploit his aircraft's superior sustained turn rate, found himself instead trapped in a violent, high-speed, three-dimensional chess match, where every move he made activated a counter-move, designed to exploit his weaknesses. By Mid-1944, this tactical doctrine had been refined to the point of systematic execution. Training syllabi included specific power settings, specific airspeed gates, specific G-loading profiles for each phase of the engagement. The American pilot was not relying on instinct or improvisation. He was executing a rehearsed sequence designed to maximize his advantages and minimize enemy strengths. The Dreitzen to 1 kill ratio was not the result of pilot skill superiority. It was the result of a tactical system engineered to convert industrial advantages, more power, more ammunition, more structural strength, into geometric certainty. The Zero pilot was not fighting a better aircraft. He was fighting an entire doctrine built around the weaponization of excess. The most devastating weapon deployed above the Philippine Sea on June 19, 1944, was not the F6F Hellcat 6, 50 machine guns, nor the 2800 engines 2,000 horsepower. It was the systematic destruction of fair, Japanese fighter pilot confidence, a psychological collapse so complete that it rendered even veteran aces tactically impotent. The Dreitzen to 1 kill ratio was not merely a statistical outcome, it was a death certificate for an entire philosophy of air combat. To comprehend the magnitude of this psychological defeat, one must first understand the foundation upon which Japanese fighter pilot identity was constructed. For 3 years, from Pearl Harbor through Midway, Guadalcanal, and the grinding attrition of the Solomon Islands campaign, the Zero pilot had been the unchallenged master of the turning fight. His superiority was not theoretical. It was written in the wreckage of hundreds of American aircraft and the confirmed kill tallies of Japan's elite aces. Men like Hiroyoshi Nishizawa, with 87 confirmed victories, or Tetsuzo Iwamoto, with 80, were not merely skilled pilots. They were living proof of a doctrine that held individual mastery and spiritual dedication could overcome material disadvantage. The Zero pilot entered combat with an absolute certainty. If he could force the American into a turning engagement, victory was geometrically guaranteed. This certainty was the psychological bedrock of Japanese fighter operations. Then, beginning in late 1943 and accelerating through the spring of 1944, this certainty began to crack. American pilots were no longer fleeing from turning fights. They were initiating them. The geometric laws that had governed 3 years of aerial combat were being violated with increasing frequency, and Japanese pilots were dying in scenarios that should have been impossible. The first reports were dismissed as isolated incidents, perhaps the work of a few exceptionally skilled American pilots flying aircraft that had been specially modified. But as the incidents multiplied, as the loss rates climbed, as veteran pilots with 30, 40, 50 confirmed kills failed to return from missions, a terrifying realization spread through the ranks. Americans had solved the Zero. The psychological impact of this realization cannot be overstated. For a fighter pilot, confidence is not a luxury, it is a tactical requirement. Hesitation in combat, even momentary uncertainty, translates directly into reaction time delays measured in tenths of seconds. In a turning fight, where firing opportunities exist for 2 to 3 seconds, a 10th second delay in trigger squeeze is the difference between a kill and being killed. Japanese pilots who had previously entered combat with absolute certainty in their tactical superiority now faced a profound cognitive dissonance. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now back to the story. The geometric facts remained unchanged. The Zero could still complete a tighter circle, but the combat outcomes had inverted. American pilots were achieving firing solutions in scenarios where such solutions should have been impossible. The psychological response was predictable and catastrophic. Doubt. This doubt manifested in specific, measurable tactical behaviors. Japanese pilots began breaking off engagements earlier, disengaging from fights they would have previously pressed to conclusion. They became more defensive, more conservative, more focused on survival than on achieving kills. This psychological shift created a vicious cycle of degrading performance. The American tactical system was specifically designed to exploit this psychological vulnerability. The Hellcat pilot who aggressively turned into a Zero at high speed was not merely executing a maneuver, he was presenting an impossible scenario that violated the Japanese pilot's tactical understanding. The Zero pilot, confronted with a Hellcat turning toward him rather than away, faced an immediate decision point: commit to the turn or disengage. If he committed, he entered the exact tactical trap the American doctrine was designed to create: a high-speed, energy-dynamic engagement where Hellcat advantages were maximized. If he disengaged, he surrendered the initiative and confirmed to himself that the Americans had achieved tactical parity or superiority. Either choice reinforced the psychological erosion of confidence. The scale of this psychological warfare becomes apparent in the combat reports from June 19th, 1944. American pilots repeatedly described Zero pilots who broke off attacks prematurely, who failed to press advantages, who exhibited what the American assessment termed lack of aggressive spirit. This was not cowardice. This was the rational response of skilled pilots who recognized they were operating in a tactical environment that no longer favored their aircraft or doctrine. The most psychologically devastating aspect was the targeting of veteran pilots. The Japanese training system, constrained by fuel shortages and time limitations, produced pilots with minimal flight hours but relied on experienced aces to lead formations and mentor newer pilots. The American tactical doctrine specifically prioritized killing these formation leaders. Decapitation strike became standard operating procedure. Upon entering combat, Hellcat pilots would identify the most aggressively maneuvering Zero, usually the formation leader, and concentrate fire on that aircraft. The loss of the formation leader created immediate tactical confusion among the less experienced wingmen, who lacked the training or experience to adapt to fluid combat situations. Between January and June 1944, the Imperial Japanese Navy lost an estimated 180 fighter pilots, with more than 20 confirmed victories. These were not merely skilled aviators, they were the institutional memory of Japanese fighter doctrine, the men who understood the Zero's capabilities and limitations through hundreds of hours of combat experience. Their loss created a knowledge vacuum that could not be filled. The replacement pilots arriving at frontline units by mid-1944 were catastrophically undertrained. Flight training hours had been cut from 700 hours to less than 200 hours. Many pilots arrived at combat squadrons with fewer than 900 hours total flight time and less than 20 hours in the Zero. They were thrust into combat against American pilots who, while also relatively inexperienced, were flying aircraft that forgave mistakes and executing tactics that systematized victory. The psychological impact on these novice Japanese pilots was absolute. They entered combat knowing they were undertrained, under-equipped, and facing an enemy who had systematically defeated their most skilled predecessors. The expectation was not victory, but survival. This mentality created a self-fulfilling prophecy of defeat. The Great Marianas Turkey Shoot crystallized this psychological collapse into a single catastrophic day. Approximately 373 Japanese carrier aircraft attacked the American fleet. American Combat Air Patrol, consisting primarily of F6F Hellcats, intercepted the incoming strikes. The resulting engagement was not a battle. It was an execution. Japanese pilots, many, on their first or second combat mission, faced American pilots executing a refined, systematic, tactical doctrine supported by superior aircraft performance. The psychological disparity was so profound that many Japanese pilots never achieved firing position. They were shot down while attempting to maneuver defensively, killed while trying to disengage, or simply outflown by American pilots who controlled every aspect of the engagement geometry. The Americans lost 29 aircraft in combat. The Japanese lost 243. The kill ratio of 13:1 was not the result of numerical superiority. The American force was larger, but not by a 13:1 margin. It was the result of complete tactical, technological, and psychological dominance. The aftermath of June 19th marked the effective end of Japanese carrier aviation as a strategic force. The loss of experienced pilots was irreplaceable. The destruction of aircraft could be remedied, but the destruction of confidence could not. Japanese fighter pilots who survived the battle carried with them the knowledge that American pilots had solved the Zero's superiority. This knowledge spread through the ranks with the efficiency of a virus. In subsequent engagements throughout 1944 and 1945, Japanese fighter pilots increasingly avoided combat when possible, resorted to kamikaze attacks when avoidance was impossible, and demonstrated what American intelligence assessed as systematic degradation of tactical proficiency. This was not a failure of courage. This was the rational response to an unwinnable tactical situation. The final, most damning psychological element was the recognition among Japanese pilots that their opponents were often demonstrably less skilled in traditional measures of piloting ability. American pilots with 200 hours of total flight time were routinely defeating Japanese pilots with 500 hours of combat experience. This inverted the fundamental assumption of Japanese fighter doctrine that superior skill could overcome material disadvantage. The realization that the Americans had created a system where skill was rendered less important than doctrine, where individual excellence was subordinated to collective execution, destroyed the philosophical foundation of Japanese fighter operations. The samurai ideal of the lone ace achieving victory through personal mastery was rendered obsolete by the industrial reality of systematized tactics executed by adequately trained pilots in superior aircraft. The Hellcat did not defeat the Zero through superior turn performance. It defeated the Zero by destroying the psychological certainty that had sustained Japanese fighter pilots for 3 years. The 13:1 kill ratio was not a measure of aircraft performance. It was a measure of how completely one tactical philosophy had annihilated another. The lesson was unforgiving. In industrial warfare, confidence is not built on individual skill, but on systematic advantage. The Zero pilot's mastery was irrelevant when confronted with an opponent who had weaponized excess, systematized tactics, and created a doctrine that made victory a statistical probability rather than a test of skill. The psychological collapse was complete, absolute, and irreversible. The Zero, once the symbol of Japanese aerial supremacy, had become a symbol of inevitable defeat. The smoke cleared over the Philippine Sea on the evening of June 19th, 1944, revealing not merely a tactical victory, but the final, irrefutable proof of a mathematical certainty that had been building since the first 24 rolled off the Willow Run assembly line. The 13:1 kill ratio was not an aberration, it was the inevitable conclusion of an industrial equation where one variable, American production capacity, had grown so enormous that it collapsed every other factor in the calculation. The Hellcat's tactical revolution, the geometric innovations that allowed it to turn inside the zero's circle, existed only because of a foundation so vast, so overwhelming, that it rendered the very concept of tactical parity meaningless. To understand the true scope of the victory, one must zoom out from the individual dogfight, from the specific engagement geometry, and confront the staggering industrial reality that made those dogfights possible in the first place. By June 1944, the Grumman Aircraft Engineering Corporation had delivered 545 F6F Hellcats to the United States Navy. This number, impressive in isolation, becomes genuinely terrifying when placed in comparative context. In the same period, from January 1943 to June 1944, the Empire of Japan produced approximately 630 fighters, of all types: Zeros, Hayates, Raiden, Shiden, combined across all manufacturers, all variants, all theaters of operation. The United States was producing Hellcats alone at a rate that matched Japan's entire fighter output, while simultaneously producing thousands of 51 Mustangs, 47 Thunderbolts, 38 Lightnings, and 4 Corsairs for the Army Air Forces and Marine Corps. The production disparity was not a matter of degree. It was a matter of existential difference between two industrial civilizations operating in fundamentally separate economic universes. The tactical innovations that allowed Hellcat pilots to defeat Zeros in turning engagements were engineered solutions to a problem that Japanese pilots faced with no possibility of an engineered response. When an American pilot executed a high-speed reversal that exploited the Hellcat's superior roll rate, he was deploying not merely a tactic, but the accumulated industrial output of the Pratt Whitney factory in East Hartford, Connecticut, which was producing 2,800 engines at a rate of 4 units per month by mid-1944. When that same pilot firewall his throttle to war emergency power, climbing away from a Zero that lacked the power to follow, he was burning high-octane aviation fuel refined from the dry 100 million barrels flowing annually from Texas and Oklahoma, oil fields. When he squeezed his trigger and sent 320 rounds of 50 caliber ammunition into a 60-foot cone, he was deploying the output of the Lake City Army ammunition plant, which was producing 4,5 million rounds of 50 caliber ammunition per day. Every tactical advantage, every geometric innovation, every successful engagement was underwritten by an industrial capacity that Japan could not match, could not counter, and fundamentally could not even comprehend. The Zero pilot who died in a turning fight with a Hellcat was not defeated by a better pilot or even by a better aircraft. He was defeated by the continental United States, by the inexhaustible geology of American petroleum reserves, by the endless aluminum ingots pouring from Alcoa smelters, by the 500 women working defense plant shifts in Michigan and Connecticut. The scale becomes even more staggering when examining the logistical architecture that sustained the tactical system. The carrier task forces, operating in the Philippine Sea, were not merely collections of warships. They were floating industrial ecosystems, mobile extensions of the American manufacturing base projected Zeben, miles across the Pacific Ocean. Each Essex-class carrier arriving at the front line carried not just aircraft but a complete maintenance and supply infrastructure designed to keep those aircraft operational at rates that defied previous military logistics. The USS Lexington, flagship of Task Force 58, maintained an aviation supply department that stocked dry 200 different parts and components for the F6F Hellcat alone. Spare engines, replacement propellers, hydraulic fluid, oxygen bottles, ammunition belts, radio crystals, spark plugs, tire assemblies every component required to keep 630 fighters operational, was available in sufficient quantity to sustain high-tempo operations for 60 days without resupply. Contrast this with the Japanese carrier Tsuikaku, the last surviving veteran of the Pearl Harbor strike force, which by June 1944 was operating with spare parts inventories sufficient for approximately 14 days of sustained operations. Japanese maintenance crews were cannibalizing damaged aircraft to keep operational aircraft flying. American maintenance crews were discarding components with minor defects because replacement parts were more abundant than repair capacity. This logistical disparity translated directly into operational tempo, the rate at which aircraft could be launched, recovered, rearmed, refueled, and relaunched for subsequent missions. American carrier task forces were routinely launching 200-plus aircraft strikes twice per day, maintaining combat air patrol of 36 bis 48 fighters continuously, and sustaining this operational tempo for weeks without degradation. Japanese carrier forces, even when fully supplied, could not match half this sortie rate. The brutal arithmetic of attrition warfare became inescapable. American carriers lost in combat USS Hornet at Santa Cruz, USS Lexington at Coral Sea, were replaced by new construction faster than they could be sunk. The Essex-class production program delivered 17 fleet carriers between 1943 and 1945, while simultaneously producing 9 Independence-class light carriers. Japan, during the same period, completed dry fleet carriers and Fear light carriers, most of which were sunk before achieving operational status. The replacement pilot pipeline demonstrated an even more profound disparity. By Mid-1944, the U. Navy was graduating 200 new naval aviators per month from training centers at Pensacola, Corpus Christi, and Jacksonville. These pilots, while less experienced than their Japanese counterparts, were arriving at combat squadrons with 350 bis 400 hours total flight time, including 50 bis 75 hours in type aircraft. They had fired their guns at towed targets, practiced carrier landings, and executed tactical formations hundreds of times before encountering enemy aircraft. Japanese pilot production by Mid-1944 collapsed to approximately 180 graduates per month, with average training hours reduced to 150 bis 180 total, including as little as 30 hours in operational aircraft. Many pilots were arriving at combat squadrons, having never fired their guns, never practiced in formation, never executed a carrier landing. They were thrust into combat against an enemy whose rookie pilots had more training than Japan's instructors. The psychological impact of this disparity extended beyond individual pilot confidence to the institutional level. Japanese squadron commanders planning missions in June 1944 operated under constraints that would have been unthinkable 2 years earlier. Fuel availability dictated mission profiles. Ammunition loads were reduced to extend aircraft range. Combat air patrols were thinned to preserve aircraft for offensive strikes. Every decision was a negotiation with scarcity. American squadron commanders operated in a universe of abundance. Pilots were authorized to jettison external fuel tanks at the first sign of enemy aircraft, a tactical luxury that Japanese pilots could not afford. Hellcat pilots routinely engaged at full military power, burning fuel at rates that would have grounded Japanese squadrons, because the tanker fleet ensured that fuel would be available when they returned. Training missions were flown daily because aircraft availability rates exceeded 85%, a figure Japanese squadrons had not achieved since 1942. This abundance created a training feedback loop that continuously widened the capability gap. American pilots returning from combat missions were immediately debriefed, their tactical experiences documented, filmed, and integrated into training curricula. Successful tactics were disseminated fleet-wide within weeks. The Hellcat pilots executing high-speed reversals and exploiting energy advantages in June 1944, were deploying tactics refined from combat reports filed by pilots in the Solomon Islands 6 months earlier. Japanese tactical development, by contrast, had effectively ceased. Veteran pilots who survived combat rarely had the opportunity to pass their knowledge to replacement pilots who were rushed into combat. Squadron-level tactical innovations died with the pilots who developed them. The institutional knowledge base was hemorrhaging faster than it could be replaced. The industrial endgame was not merely about production numbers or logistical capacity. It was about the creation of a self-reinforcing system where material advantage generated tactical advantage, which generated training advantage, which fed back into material advantage. The Hellcat was not simply a better fighter than the Zero. It was the centerpiece of an integrated system that included the 2800 engine, the 50 caliber ammunition production line, the carrier maintenance infrastructure, the pilot training pipeline, the tanker fleet, the tactical doctrine development process, and the combat intelligence dissemination network. The Zero, by contrast, existed in isolation. It was a magnificent aircraft serving a military system that lacked the industrial depth to support it, the logistical infrastructure to sustain it, or the training capacity to replace the pilots who flew it. By mid-1944, the Zero was not fighting the Hellcat. It was fighting the accumulated industrial and military capacity of the United States, a contest so fundamentally mismatched that individual courage or tactical brilliance could not affect the outcome. The final, most damning statistic emerged in the months following the Great Marianas Turkey Shoot. Between June and October 1944, the Imperial Japanese Navy lost approximately 200 carrier-qualified pilots killed or missing in action. During the same period, the U.S. Navy graduated 800 new naval aviators and lost 340 pilots in combat. The replacement rate disparity was 14-1 Sol favor of the Americans. The attrition mathematics were inescapable. Japan was losing pilots faster than it could train them. America was training pilots faster than they could be killed. The industrial endgame was never in doubt. The tactical innovations that allowed Hellcat pilots to turn inside the Zero circle were expressions of industrial capacity translated into combat geometry. The 13:1 kill ratio was not a measure of pilot skill or aircraft performance. It was a measure of the gap between two industrial systems, one operating at the absolute limit of its capacity, and one operating with such excess capacity that it could afford to experiment, adapt, and overwhelm through sheer volume. The Zero was defeated not in June 1944, but in December 1941, the moment Japan initiated a war against an opponent whose industrial base was 10 times larger, whose oil production was 100 times greater, and whose capacity for sustained military production exceeded the combined output of all Axis powers. The Hellcat was merely the instrument through which this industrial imbalance was finally and decisively expressed in the skies over the Pacific. By the time the last Zero fell burning into the Philippine Sea, the outcome of the Pacific War had been determined not by the tactical genius of fighter pilots, but by the thermodynamic certainty of furnaces, refineries, and assembly lines operating at a scale that rendered individual battles into statistical footnotes. The 13:1 kill ratio was not victory, it was mathematical inevitability made manifest in aluminum, steel, and high-octane fuel. The war had stopped being a contest between warriors and had become an execution of industrial logic. The Hellcat turning inside the Zero's circle was merely the final, visible expression of a victory that had been calculated in production spreadsheets years before the first shots were fired. The impossible geometry of aerial combat had been solved not by better pilots or better tactics, but by the unapologetic deployment of unlimited industrial capacity against an opponent who had dared to fight a war of attrition without the material resources to sustain it.